Hi, in this video I wanted to explain how the high side and low side MOSFET drivers works. Uh, this type of circuit with these two N-channel MOSFET in series is commonly used in synchronous buck converters because it made use of the switching node to to provide a average signal to the load as it switches. So let me explain this this configuration. Is made of this first N-channel MOSFET, which has his terminal of drain connected to VDD. So this name high side is because it's connected between the load and the VDD. And the second one, also a N-channel, it has his terminal of source connected to GND. So it's called low side because it's connected between the load and the GND. So it works? When the high side MOSFET is turned on, it pulls the load to VDD. At this point, the low side MOSFET is off. When the low side MOSFET is turned on and the high side necessarily is turned off, it pulls the load to GND. This switching operation, it provides a average signal to the load. As I was saying, this type of circuit is commonly used in synchronous buck converters, so you see with very often this type of circuit used in synchronous buck converters. And we connected to make a topology of a synchronous buck converter. We connect a inductor on this switching node. That is the switching node. And on the inductor we're going to have a voltage drop VL, and if you remember, VL is equal to the value of the inductor times the derivative of the current on the inductor with respect to time. And this is the rate of change of the current on the inductor. So now I'm going to draw the current, the waveform of the current. His behave as charge and discharge. So here we have the voltage off and the voltage on when it's high and when it's low. So when at the node we have a high voltage, so the current on the of the inductor, it's going to have a positive rate of change, and as it turn it off, as the switching nodes are turned off, we're going to have a negative slope, a negative rate of change of the current. And this is a process a process that is gonna to repeat. So that is the current. You also going to see this type of topology of configuration. This circuit, draw it like this, which is pretty much the same. So as I was saying, this type of configuration is commonly used in synchronous buck converters, and it's controlled by a PWM signal, which it comes from a controller. So here we have the load, here we have the inductor, and this configuration is the same as this one. Okay, so that is the explanation that I wanted to give to you, and is useful when we are working and projecting synchronous buck converters. And as we are post more videos about buck converters on this channel, I thought that is going to be useful to our future videos in projects. So that's it. Thank you for watching.